This is the story of every UPSC aspirant. Where to start from? Which subject should I start with? Which books do I refer? How do I analyze previous year questions? Which option should I opt for? Does everyone need a guiding hand? Do you need coaching? Do I need coaching? How should I start my preparation? Do you feel lost in all these questions? Come join Yes UPSC family and let us guide you through this preparation to become an IS and not just an aspirant. Yes UPSC, guiding you to success. Hello everyone, I will be teaching you geography and we will cover all the NCERTs from class 6 to 12 chapter wise so that we don't miss out on anything. Today we will be dealing with chapter 1, the earth in the solar system. But before that, let's understand why do we study geography, why geography is important for us and how it helps us in daily life. For that, let's answer the first question, what is geography? In general sense, if we define everything we see around us, like mountains, rivers, then the establishments like industries, infrastructure, all these topics are covered under geography. But let's define it in more correct sense. Then geography is the study of physical features of the earth, atmosphere, surroundings, human activities like agriculture, distribution of population, which area contains more people, which area has more density of people. For example, there is a state which has a lot of population, there is another state or a village where only there are 200 people living. For example, in Ladakh there is less population as compared to the population of Delhi. So the population distribution and the distribution of resources, the resources, for example forest, then your water is a resource, your wind is a resource, how is it distributed, all these things combined together and their study will be called geography. In short, geography is the study of everything around us. We talk about biotic and abiotic factors, all the factors interacting together forms an environment. So this environment, when we study this environment involving all the factors, it will be geography. Now let's come to the chapter which is the earth in the solar system, and let's see what is given in this chapter. In this chapter we will learn about celestial bodies, stars, what is Purnima, what is Amavasya, what are constellations, how we know the distance of the pole star and how do we locate pole star, what is our solar system, we learn about sun, planet, how many planets are there, what is geoid, we learn about moon and galaxies. This will be the brief of the chapter which I am going to explain in the next coming slides, and we will come back to this after that to see that we have covered everything or not. Now let's understand what are celestial bodies. For example, when you look at the sky in the night, you see a lot of objects. Some of them are shining, some of them are brighter than the others, some of them twinkle, and some of them are there, but they're not blinking. They're not flashing the lights. So all these shining objects at the night in the sky we see are called celestial bodies. For example, the biggest celestial body we see near us is the sun, because it is the nearest to us, it seems bigger to us, and if we see all the stars, moon, sun, everything, if we compare, then we see the sun is the biggest which appears to our eyes. So another celestial body is moon and stars. There are some celestial bodies which are big and hot. For example, sun is very big. It is hot because we can experience the heat, and it is made up of a lot of gases. They have their own heat and light which they emit. So such celestial bodies which have their own heat and light are called stars. It is the bifurcation of celestial bodies that star is a part of celestial bodies. So for example, sun. Sun has its own light, its own heat, it glows. So it is a star also, and it is the biggest star near to Earth. Let's come to the other aspect, the celestial bodies which do not have their own heat and light. That is, they cannot glow of its own. For example, if we see Earth from the moon, we have seen in the Google pictures also, if we see Earth from the moon, it appears to be blue. But how? So Earth doesn't have its own light, it cannot glow itself. It is glowing under the light of sun. That is why it appears to be blue, because of the water present on the earth. Such bodies which do not have their own heat and light will be called planets. They are glowing, they appears to glow or they appears to be brighter in the space when we see it from the other place because of the light of the some other stars, because of some other celestial body. Such celestial bodies will be called planets. Now let's understand what is the meaning of the planet. Planet has come from the Greek word planetai, which means wanderers. Why wanderers are planets are called wanderers? Because every planet has an orbit in which it is revolving around sun. So in a simpler language, they wander around sun in an orbit. That is why they are called wanderers. Hence the word comes planetai and they are named planets. The earth which we live on is a planet. How do we know? Because it is revolving around sun and it is getting the heat and the light from sun, and sun is our nearest star. If we see Earth from the greatest distance, as I told you, it will appear to be shining because of the light it gets from the sun, and under the light of the sun, it appears to be shining. And it is called blue planet also because the water on the Earth appears in that light and it appears to be blue. So Earth is a blue planet because of the amount of water present on the Earth. Now let's talk about the satellites of a planet. What is moon? Is moon a planet? No, moon doesn't orbit around sun, but it does orbit our Earth. It is a companion of Earth and it moves around Earth. So it is a satellite of Earth. Satellite is something which is a celestial body and it is moving around a planet in a way like planet moves around the sun. Correct? So for example, moon is a satellite to Earth and a lot of planets have, like other planets, 8 other planets, they have a lot of moons. Some have more moons, some have less moons. Earth has only one moon. But let's come to the point that satellites are only natural satellites. For example, moon is a natural satellite. No, satellites are human made also. If you remember in our childhood, we used to talk about satellite phones for communication. These satellite phones used to work, they used to connect us to a satellite, and then with that satellite used to connect us to the other phone. That was a satellite phone. So that was a human made satellite sent into the space for the communication. Likewise, India has sent a lot of satellites for their purpose, like INSAT, IRS, EduSat, etc. They orbit around Earth to gather the information about our Earth, about universe, to make it easy for us to access the space and communication. Now let's observe one more thing. Then if we look at moon, it appears to be of different sizes and different shapes. For example, at times it is a hemisphere, at times it is a circle, at times not a circle but a sphere because we can see only the one side of the moon. Why is it so? Moon appears to be different at different times and we can see only once in a month the full moon, which is called the Purnima. Moon appears to be a circle but it is a full sphere. And there is a night, for example, on Diwali, which is Amavasya. Why do we call it Amavasya? Because we cannot see moon at all. And it is the new moon. Why new moon night? Because the next day of Amavasya, the moon, we will see a thin line of a moon as a thin line, and it will be the new moon going towards Purnima. Let's move further and see what is there in the sky. Apart from moon, sun, we see a lot of stars in the sky. Have you ever in your childhood tried to make images out of the star? Yes, everybody has done. So let's see what happens if we are making images out of the star. The various pattern forms from the different group of stars are called constellations. We call them constellations. At times, or maybe your grandmother or your grandfather has told you that, see, that is Saptarishi. It is a combination of 7 stars and it is a constellation. Sapta means 7 and Rishi means scissors. It is also called the small bear constellation, and the major and the biggest the constellation we have is the Ursa Major, which is called the Big Bear. Let's see how these two constellations appear. This is the Ursa Minor, which is a little bear. You can count 1, 2, 3, 4, 5, 6, 7 stars are there. That is why it is Saptarishi. Sap means 7. And this is the Ursa Major. It is called Great Bear because it's kind of forming the entire image of the bear. You can see. You can notice that in the sky when today at night try to find out the Ursa Major and the Ursa Minor. Let's see how pole star was important. Pole star is a star which has a fixed location and it is always in the north. And We can locate the location of the pole star with the help of Saptarishi constellation. Why a pole star is important? Because in ancient time, how we are going to find where is the north? People didn't have the magnetic compass. They cannot find the location. How they will travel? If they know the north, they can know south, east, and west. So with the help of the pole star, they used to find the direction. And how do we find the direction of the pole star? If you see this is the Ursa Minor or the Saptarishi, and if you see the pointer stars, these two stars, and extend the line to a star, then this star will be the North Star or the Pole Star. So this is how they used to find out the direction in the ancient times. Now let's see the bigger picture, that there are celestial bodies, there are planets, there is sun, there is moon, there are other moons to other planets. Then what is all this called? All this together is called solar system. The sun, the planets, satellites, and some other celestial bodies known as asteroid or meteoroids, which we will discuss later, they are called together a solar family, which sun is the head, and together they are called solar system. Why solar family? Because in Roman mythology, Sol means sun god, and solar is related to sun. So the family of sun will be called the solar family, and you can see the family of sun here. This is the sun, and the planets are revolving around it, and the moons are revolving around these planets. Okay, and these are the asteroids, meteoroids, the other celestial body, and the stars. Now you can see that this planet Saturn has rings around it, but Earth doesn't have rings around it. Jupiter, Saturn, and Uranus, they have rings around them, and these are the belts of debris, small rocks, and they are revolving around Saturn. And these rings can be seen from the Earth also with the help of a very powerful telescope. And interesting fact is that we cannot see them with bare eyes, but the powerful telescope. One more interesting fact I would like to tell you, that you may think at times that why we are discussing everything at night, that stars are visible at night, moon is visible at night, why not in the daytime? Because the brightness of the sun is so much that the brightness of the stars is appearing to be less to our eyes. And sun is very close to us, so it appears to be bigger and brighter to us. And the stars are very, very far away from us. That is why they appears to be small, and their brightness appears in the night only, not in the daytime. We can see in this there are only 8 planets. There is no Pluto. Earlier we used to count Pluto also as a planet, but now Pluto is called dwarf planet. What is a dwarf planet? Dwarf planet is a celestial body which does not qualify as a planet. How? It is a star that is massive enough to round it by its own gravity, but has not cleared its neighboring region of planetarians and is not a satellite. That is, it is not a satellite. It is not revolving around a planet. It is revolving around sun only like other planets. But it is massive enough so that its own gravity can drive its rotation. Okay, but it is not, still not qualified as a planet because it doesn't have features like planets. One may question one more thing, that how planets and stars are different. Very big difference is there. Planets do not have their own light to shine. They shine, or you can see them from the space in the light of sun. But stars are celestial bodies which can shine of their own. They have their own light. Now let's study in detail the individual part of the solar system. First of all, let's study the sun. As of now, we know that it is nearest to us. It has its own light. It is the center of the solar system. It's made up of gases. It is extremely hot, and Earth experiences temperature in the day because of sun, and it is colder at the night because sun doesn't appear. But one more interesting thing is that we feel the heat of the sun because it's nearest, but it is still very far from us. It is 150 million kilometer away from us, and it takes 8 minutes for the sun's light to reach us. Why? Because the distance is so much that even if we calculate the speed of light and see, it still takes 8 minutes to reach us. So we know about planets, now, and we know there are 8 planets, which is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. And to remember this, there is this thing: my very efficient mother just served us nuts. My for Mercury, V for Venus, E for Earth, M for Mars, J for Jupiter, S for Saturn, U for Uranus, and N for Neptune. This is very easy to remember, that all the 8 planets in the order. Mercury is nearest, second planet is Venus, third is Earth, fourth is Mars, and so on. The eighth one is Neptune. And all the planets are revolving Sun like Earth in a fixed path, which is called orbit. And as we can see from the last image, orbits are elliptical. They are revolving in the elliptical orbit, and this is the Sun. Every planet is revolving like this. So 8 planets, 8 orbits, Sun. These are the some facts which you should remember, which is Mercury is nearest to Sun, and it takes 88 days to complete one round along its orbit. In contrast, if we talk about Moon and Earth, and Moon takes 27 days to orbit Earth, and Earth takes 365 days to orbit Sun. That is why we call it a year. And it takes 88 days to complete one round along its orbit. So Mercury is fastest. Why it is faster? Because it's close to Sun. Mercury is here, this is Sun, and this is Earth, for example. This is your Venus. So its orbit is also smaller. Now it has to cover less distance. Earth has to cover more distance. And as we go to the Neptune, which is the 8th planet, it will cover more distance, so it will take more time. And it also depends on the gravity and the speed of the planet. If the gravity is more and the speed is more, obviously longer distance will also be covered in less days. Venus is covered Earth's twin. Earth's twin, they are similar in some sense. How they are similar in size, they are similar in shape, and that is why it is Earth's twin. So remember, Venus is the Earth's twin. This is again that Pluto was considered a planet. Now it is considered a dwarf planet. Let's know about Earth. So Earth is the 3rd planet from the Sun, and in size it is 5th largest. That means there are 4 more planets which are bigger than Earth. Earth has a shape called geoid. What is geoid? That is, Earth is little flattened at the poles. It is not a sphere. This is sphere. It is not a sphere. This is not Earth. Earth is little like this at the poles. It is little flattened at the poles. So this is called geoid. And later on we will study that poles are not these straight. This is not a perpendicular line. Earth is little tilted at its axis, and it is like this. This is the North Pole and this is the South Pole. We will study these things in the later chapters. And we have water on Earth, we have air on Earth, we have essential things for survival like food, forest, everything. We have oxygen. That is why the Earth is an important planet, because it has conditions favorable to support life, and that is why it is a unique planet in solar system. Again, I told you the Earth appears to be blue from the outer surface because of the 2/3 surface is water, hence it is called blue planet. So let's study Moon now. Moon is a satellite, we know till now, and the diameter of the Moon is 1/4 of the Earth. That is, it is 1/4, 1/4 of the diameter of the Earth. Now you can imagine, if Earth is this, then the Moon is this size. 1/4 of the Earth. This is your Earth, and this will be your Moon. And you can see this is the orbit of the Moon, and the Earth is orbiting around Sun. Sorry, Moon orbits Earth, and the Earth will orbit Sun. So this is this direction, and this is this direction going. Okay, now I think this will be clear. It appears to be big again because it is a celestial body which is close to our planet, but still it is so many kilometers away. Moon again revolves around Sun in 27 days. That is why we call it a month. Does Moon have life? No, it doesn't have air or water. It has mountains, plains. When you see the Moon on the Purnima, you see shadows on the Moon. These are the depressions and the plains on the Moon which appears to be like shadows on the Moon. Now let's understand what are asteroids and meteoroids. There are stars, there are planets, there are satellites, but there are a lot of small bodies. We have heard in the news that an asteroid struck Earth or meteoroid struck Earth. What are they? These are the asteroids. Small bodies which are not planets, which are not stars, which are not satellites, but are celestial bodies revolving in our galaxies. They are found between the orbit of Mars and Jupiter. We have seen a belt of debris after Mars and before Jupiter. What is this? This is the asteroid belt. A lot of asteroids are present around Sun in this belt. This is called asteroid belt. Now, what are meteoroids? They are small pieces of rocks. You can see these are the rocks which are moving around Sun. Sometimes they fell down on Earth, and due to the friction, they burn also. Heat is generated and a depression is created. So these are meteoroids. Now let's understand what is galaxy. We live in a galaxy called Milky Way, and you can say this is the galaxy. Now see the image very carefully and see there are a lot of stars. There are a lot of gases and rings. Then there is sun inside. Here is sun, and these are the orbits of the planets. So million stars, planets, sun together. Solar system is part of this galaxy. It's called galaxy. Why is it called Milky Way? Because earlier we used to call this Akash Ganga, that is the river flowing in the sky of light, the river of light. That is why Akash, the sky, river of light, Ganga, Akash Ganga. Now let's understand the relationship between the planet, solar system, galaxy, universe. Let's see, this is you. So you live in a house. Your house is Earth. Okay. Earth belongs to solar system. So your house lies in a colony, and that colony will be solar system. Now solar system we studied is a part of a galaxy. So the city you live in is your galaxy. And galaxy, there are a lot of galaxies. This is galaxy 1, this is galaxy 2, this is galaxy 3, and so many are part of one big system which is called universe. So this was the chapter 1, and do revise it through the mind maps. It covers everything. Let's see once the mind map covers everything or not. So this mind map covers everything: asteroid, meteoroids, the name of the planets, how do we locate pole star, and solar system, what it comprises of, what is full moon, what is new moon. Everything is covered in this, and you can revise your whole chapter using this mind map.
In chapter 1, we have learned about our solar system. Let's concentrate on our Earth now. So, in chapter 2, we will read about globe, latitude and longitude, parallels of latitude, heat zones of Earth, prime meridian, relation of a longitude and time standard, and time zones. So, let's start with the chapter 2 and understand what a globe is. Globe is nothing but a true model of miniature form of Earth. You know, this is a globe. We have seen this in our schools, in offices, etc. And we see this looks like exactly the Earth. But it is not our Earth. It is a small miniature model of the Earth. Globes may be of varying size and type. Big ones which cannot be carried easily, small pocket globes, and globes like balloons which can be inflated and are handy and carried with ease. Countries, continents and oceans are shown on the globe to give us an idea about their shape and approximate location. See, this is Africa on this globe, this is India, this is Indian Ocean on this globe. So we know the shape of India is like this on this globe. Africa is something like this. This is the border of Africa. But can we travel from one place to another without knowing the actual locations? Can you say how much time does it take to travel from here to here? No. And to know the exact locations, we need some important information regarding the exact locations calculation. So, let's understand some basic facts and features of our planet Earth. If we notice globe, a needle is fixed through the globe in a tilted manner. You can see the Earth is tilted towards this, and this is the needle fixed in the center of the Earth. This line which is made by the needle, this line joining from here to here. This line is passing through the center of the Earth is called the axis of the Earth. This is the axis of your Earth, around which the globe can rotate. Likewise, our Earth rotates from west to east. Earth is rotating from west to east. Okay, so west is in your left and east is on the right. So along this axis, Earth will rotate. This is called axis of Earth and the rotation of Earth around its axis. Now we notice the ends of this needle. These are the ends of this needle. So the end at the northern side is called North Pole because it is in the northern direction, and the southern end, this is called the South Pole of our Earth. Now you may think Earth has such needle and North Pole and South Pole marked on Earth, but no. This axis of imaginary line in case of real Earth, that is, these are only imaginary lines for our understanding, that at the center of the Earth passes a line which is called axis of Earth, and the upper tip of the needle or the line passing is the North Pole, and the southern tip or the southern point where it ends is the South Pole. Let's talk about other imaginary lines drawn for miniature Earth or globe for our understanding. This is not only the line drawn on Earth, there are other lines which are also drawn on Earth for our better understanding. The line passing through the center of the Earth horizontally. See, we know this is horizontal and this is vertical. So this line which is passing through the center of Earth, and it is a vertical line, and this line is at the center. So it is dividing Earth into this part and this part. Okay, can you see? So this is called equator or 0 degree. Why we call it a 0 degree, we will study later. So the line which divides Earth into two equal parts, and it is a horizontal line, is called your equator. The northern half. Why it is northern half? Let's see. This is the symbol. This is north direction. This is south. This is your east, and this is your west. So towards the north, the portion divided by equator, this is called your northern hemisphere. And in the south, this is called southern hemisphere. Now, as we say that the equator is a line passing through this, does it really a line? So if you draw a line from A and you know Earth is a sphere, so does it end at a point B or it reaches back A? Since it is a sphere, Earth is a sphere, this line drawn from here to here will come back covering the whole circle and to the point A again. So this is not actually a line, this is a complete circle which is dividing. As you know, if this is a hemisphere, the base of the hemisphere is a circle. This is the line of the equator. So in real, equator is an imaginary circular line and is very important to locate places on Earth. In reference to equator, we will learn how to locate places. Now if we draw lines parallel to equator, see this line is parallel to equator. This is again another circle drawn parallel to the circle of equator. This is another circle drawn parallel to the circle of equator. This is another circle drawn parallel to the circle of equator. So these parallel lines are called latitudes. Latitudes are what? Parallel lines to the equator. In southern hemisphere also and northern hemisphere also. 3 lines you can see here. But these are only 3 lines. These are the important latitudes. Okay. There are in n number of latitudes you can draw from here to here. Then from here to here. Now let's understand why in degrees do we measure latitude. So imagine this is your earth. And if we draw a circle, this is the tilt of the earth, and if we draw a circle vertically, this is a circle we draw on earth vertically. As you can see, these lines are drawn on earth vertically. We see that the distance between the equator and either of the pole, center of the earth and either of the pole, this is your equator. Center of the earth and either of the pole, this is north pole, this is south pole. This is the distance between center of the earth and north pole. This is the distance between earth and the south pole. So this is a complete circle, then this is 1/4. Okay, and complete circle is 360 degrees. So 1/4 will represent 90 degrees. So therefore the north and the south pole represent 90 degrees. See, north pole is 90 degree north because it is in north, and south pole is 90 degrees south because it is in the south direction. Yeah, or we can say north hemisphere and southern hemisphere. All these parallels in northern hemisphere are called north latitudes, which are indicated by N because they lie in the northern hemisphere. And all these parallels of latitude in southern hemisphere are called southern latitudes, and they are represented by S. See, we have written S here, we have written N here. Okay. Now let's see and observe one thing. All these latitudes are of the same size. Can you see this latitude, this are the same size? No. They are decreasing as we go towards the pole. Since Earth is a hemisphere, the size of the latitudes go on decreasing from equator to poles. Let's discuss some important latitudes we know. Tropic of Cancer, which is 23 degree and a half north in northern hemisphere. Then there is Tropic of Capricorn, 23 degree and a half south in the southern hemisphere. Then there's Arctic Circle, which is 66.5 degrees north, and there is Antarctic Circle, which is 66.5 degrees south, respectively in northern hemisphere and southern hemisphere. So till now we have understood what is southern hemisphere, what is northern hemisphere, what are parallels of latitude, what are the important latitudes, etc. Moving further, let's understand the heat zones of Earth. We know that Earth is moving around Sun and towards its axis also. You can see that this area is closest to the Sun and the direct sunlight is approaching this area. So when direct sunlight is reaching this area between the Tropic of Cancer and Tropic of Capricorn, this area will get maximum heat and this is called torrid zone. The midday sun, it is 12 o'clock, the daytime sun, when all say that sun is overhead. What does that mean? So midday sun is overhead at least once a year on all latitudes in between 23 degree half north, 23 degree and half degrees south. So this area will receive maximum heat and sun is at least once overhead. You can see at least once in a year that sun will appear on your head in a day. Does midday sun crosses these two latitudes? Can it cross this point and this point? No. The latitudes beyond this received angled sun rays. That is, the rays of sunlight is a low angle. So the places on earth receiving these rays receive less heat because the distance is more. See, they have to travel here this much and here they will travel more distance. So as they will travel the distance, they will cool down also. Okay. So the heat reaching this area will be giving less amount of temperature to this area as compared to the torrid zone. So these are called temperate zones, which receive less heat as compared to the torrid zones. These areas are bound by the Tropic of Cancer and Arctic Circle in the north. This is the Arctic Circle, and in south, Tropic of Capricorn and Antarctic Circle. This area, this is southern temperate zone, this is northern temperate zone. Now if we observe, the angle of sun rays is decreasing as we move from equator to pole. This is here direct, that means it will be here a 90-degree angle. Now towards this is reducing, and as we reach the pole it is decreasing more. So the heat approaching the poles, the southern pole and the northern pole, will be much less. So these areas are generally cold and are called frigid zones, that is very cold zones. For both it is applicable, southern hemisphere also and the northern hemisphere also. Now let's understand what is longitude. Why do we need longitude? Let's understand with an example that why do we need longitude. As we are dealing with longitude and latitudes to understand the position of a place or a location of a place, let's understand, as we know that this is equator, this is your one latitude, this is your another latitude. So if we say that city A and B are located at the same latitude, so city A can be here and city B can be here. But can you say if they are at the same latitude, they are at the same place? No. So we cannot find the exact location of city A and B. Are A and B same cities? No, we cannot tell. So for that, we need some extra information to find out, are cities A and B a same city or they are at a different location? For that, we need to understand longitudes. So now what are longitudes? Lines, vertical lines from northern pole to southern pole. You can see these lines drawn here from north pole to the south pole here, which will tell you how far a place is from east to west. These lines, remember, longitude will tell you west and east of a place, and latitude tell you north and south. So we represent longitude with W and E and latitudes with north and south, as I told you. Again, the distance between two longitude is measured in degrees, and here each degree is divided into minutes, further in seconds. That is, longitude is related to your time. Now we can see that they are semicircles. You can see this is a semicircle. If you complete the circle, whole circle, this will be two longitudes, one in this side, one on the other side. And also observe that all the longitudes, this one, this one, this one, they are meeting at this point and this point. That is, all the longitude meet at North Pole and South Pole respectively. And at towards the pole, the distance between the meridians, longitudes are also called meridians. The distance between them is decreasing. In fact, it is zero at the poles because they meet here in southern and northern poles. See one thing, that the longitudes are same. The length of the longitudes is same. The difference is they just meet at pole. The distance between the two longitude decreases as we go towards the pole, but the length of the longitudes, all the longitudes, is same. There are many longitudes, so countries together divide. The counting of the meridians will start from a longitude passing through Greenwich meridian. Why Greenwich was selected? Because British Royal Observatory is located at this place, so they decided that this will be called prime meridian or 0 degree meridian or prime meridian. Now we see that we can move in east and as well as west from prime meridian, so we can count 180-degree east and 180-degree west from prime meridian. Why I am saying 180 degrees only? Because Earth is a sphere, so the complete circle will be 360 degrees. So if we go from here in east, I will cover 180 degrees. If we go from here to west, we can cover 180 degrees. So the 0 degree longitude and 180-degree longitude, which will be on the back side of this, will divide Earth into two equal parts. Again, see, I draw a vertical circle on Earth. This is your 0 degree and this will be your 180 degree, and like we cut an orange, this will be one circle of one hemisphere of the Earth and this will be another hemisphere of Earth. You can see this will look like if we cut the Earth into two halves. Okay, so this part which is in the east is called eastern hemisphere and in the west it is called western hemisphere. Now let's talk about one more thing. We saw that we can move 180 degree from here to here and then 180 degree from here to here. 180 degree east latitude and 180 degree west latitude, are they different lines or they are same? If this is a circle and here to here this is 180 degree and from this point to here this is 180 degree, will this be a same line or not? Yes. So similarly these two are same longitude, they are not different longitude. The longitude are the vertical lines, okay, and latitudes are the horizontal lines on Earth. We have studied all these things to understand the location of a place. Now try to find out a location of a place. For example, we are given a place A here. So we know these vertical lines are the longitudes. So this is 90 degree and this is 30 degree. This is 90 degree meridian. So we know that this place A has 90 degree west direction. Why west? Because if this is prime meridian as given here, it is in the west direction. So it will be 90 degree west. Now we know the direction west. Now we want to know the north and south. So from here to here, it is moving, making an angle of 30 degree. So it will be a latitude of 30 degree. So it is 30 degree north. So on a globe where these two lines will intersect, this is this place A. Okay, so this is the location of point A. So if you are given the coordinates, you can find that 30 degree comes here and then 90 degree intersects it here. So the place A is here. Or if the place is given, you can find out which meridian it is and which latitude it is, and you can find the location in detail. Now let's see what is longitude and time. As I told you, longitude is related to time. In earlier times, people calculated local time using the shadow cast by sun. The shadow of the sun is shortest at midday or noon and the longest at sunrise and sunset. So the local time was calculated if the sun is overhead, oh it's noon. If the sun is going below the horizon, it's evening. So when sun is overhead prime meridian, all the places will have midday. Why? Because all the countries decided together that this will be the longitude we will treat for every country. But as Earth is rotating from west to east, the places to the east of prime meridian, now Earth is rotating from west to east, but when we decided one longitude, prime meridian, we did not consider that. So if Earth is moving like this, in this figure you can see Earth is moving like this. So the places in the east will see the sunrise first. So their local time will be ahead of the time of prime meridian because they will see the sun first. And as we see west, the sun will appear here later. So they will be behind Greenwich time. Now let's calculate the time. How do we calculate time? Earth rotates 360 degrees. One more thing. So when we go towards west, we lose a day, and we go towards east, we gain a day. How? Let me tell you. The earth rotates 360 degree in how many hours? In 24 hours. Okay. So 1 hour will be what? 1 hour it rotates how many degrees? 15 degrees. That is 360 divided by 24. That is in every 1 hour it will rotate 15 degree. So 1 degree rotation will be equal to 4 minutes. That is, earth takes 4 minutes to rotate 1 degree. So if we move 1 degree in east, time of prime meridian is 12, and we move 1 degree here, so it will be 12, 4. 12 o'clock and 4 minutes. Okay. And if we move 15 degree, it will be 1 o'clock. Understanding my point? And if we move towards the west, 15 degree west, then it will be 1 hour less. That is 11 o'clock. If we move 45 degrees west, it will be 3 hours less. That will be 9 o'clock. Now, what is international dateline? International dateline is the 180-degree meridian. Why? Because if we move from here towards east, we will gain a day, because as you cross 180 degrees, it will be another day. The time has completed. 180 degrees means 12 hours complete. One ahead. If it is 12 noon here, it will be the next date 12 noon here. And if we move backwards from here, it will be the yesterday 12 noon. So when we move from west to east of international date line, we gain a day. And when we move from east to west of international date line, we lose a day. Now let's understand the concept of standard time. We saw that the countries have decided that there will be a Greenwich time which all the countries will follow. But is it okay to follow one time that America and India have same time? Is it feasible? No, because the time difference is so huge. The longitude, so the countries decided to follow as per their longitudinal and latitudinal extent the standard time zones of that country. The longitudinal and latitudinal extent of India is from 68 degree east to 97 degree east, approximately 30 degrees difference. And this is 8 degree to the north, this extent. And here it is your 36 degree north. So this is again around 30 degrees. So the state like Sikkim, which are in the east, they will see the sunrise first. And so the states in east like Sikkim, Arunachal will have different local time as compared to the states of Maharashtra, MP and Gujarat. As we go westward, because these are in east and they will see the sun first, they are west states, so they will see the sun later. But if a country has different times at different places, how the economical, administrative functioning of the country will be possible? For example, it is 11 o'clock in Sikkim, but it is 9 o'clock in Gujarat. How are we going to manage? So, to avoid that, countries adopted a standard meridian, and a time at that meridian will be treated as the standard time of the entire country. For India, such meridian is 82 degree east meridian. So the time at 82 and a half, this is written 82 degree, this is 82 and a half degree east. So the time at 82 and a half degree east meridian will be treated as the time of India, and it is called Indian Standard Time. So the time in India will be same as the time at 82 and a half degrees east. So Sikkim and Gujarat will have same time as the time as 82 and a half degree east. Some countries are even bigger than India in longitudinal extent. For example, this is India on this map and this is Russia. This is so bigger than India. So such countries which have a very large longitudinal extent decided to adopt more than one standard time, and when these people reach a place with different standard time, for example, this has a different time zone, this has a different time zone. When a person from here reaches here, they will adjust their watches as per this time zone. And Russia has 11 time zones, as this is such a big country. Earth is divided into 24 time zones, with each time zone having longitudinal extent of 15 degree. As we discussed, 15 degrees is equal to 1 hour. So Earth is divided into 24 time zones because one rotation of Earth around its axis, which gives us day and night, is 24 hours. This is the mind map of this chapter, and let's see what we have studied in this chapter. We studied latitude first. Latitudes are imaginary lines around the earth parallel to the equator, we know, and these are called parallels also. Then characteristics: latitudes gradually decrease in size from equator towards the pole. We saw that degree of latitude is greater than that of a pole. Correct? As we move, the degree increases. Latitude of a place is the angular distance measured on either north or south of from the equator. We saw that when we saw the how to calculate a location of a place. This is the angular distance. This was place A, and we saw this angle was the latitude. So this says that. And there are some facts we should remember. The distance between latitudes are constant. Okay. And the length of 60-degree latitude is half the length of the equator. This is based on the concept of circles. And length of 75-degree latitude is 1/4 of the length of the equator. Important latitude lines we studied, that is equator 0 degree, largest of all latitudes and also called 0 degree latitude. Then Tropic of Cancer 23.5 degree north, Arctic Circle 66.5 degree north, then Tropic of Cancer 23.5 degrees south and Antarctic Circle 66.5 degrees south. Then we studied longitude. Longitudes are the series of semicircles. Remember I told you that the two longitudes will make one circle. They are passing from north to south direction, crossing the equator, and they are also called meridians. All meridians are equal in length as we saw, but they meet at pole. Meridians extend up to 180 degrees from east and west of prime meridian. All meridians cross the equator at right angle, correct? They are all crossing the earth at right angle. Then 0 degree meridian or prime meridian. This was chosen in 1884. It divides the sphere into two equal hemispheres. One is western hemisphere and the other is eastern hemisphere. It passes through Royal Astronomical Observatory at Greenwich. That is why the Greenwich was chosen. This has been adopted internationally as a standard meridian, as we have studied. Longitude of a place is measured either east or west of the prime meridian, correct? What are the positive longitudes now? Longitudes counted west of a prime meridian are called positive longitudes, and negative longitudes are longitudes counted east of the prime meridian. They are negative longitudes. So this is in brief the chapter. Now let's discuss some questions based on chapter 1 and 2 on the line of UPSC so that you get a better understanding and how to answer the questions of geography in your prelims examination. The question 1 is, consider the following pairs: Mercury, a Jovian planet; Venus, duration of the day longer than that of the year; and Saturn, a planet having density less than that of water. Which of the given above are correctly matched? Let's see first. Mercury is a Jovian planet. No, we studied that Mercury is not a Jovian planet but an inner or terrestrial planet. So this statement is wrong. So any answer with 1 is not correct. So we can eliminate A, C and D. This is one method, elimination. So the correct answer should be B. But you cannot trust it blindly and see the other two statements are correct or not. Venus, the duration of day longer than that of the year. With equatorial diameter of just 4,875 km, Mercury is the smallest planet of solar system. Venus has rotation period of 243 days and revolution period around Sun of 224.4 days. Thus the planet Venus has duration of day longer than that of the year. And Saturn has the density of 0.69, which is less than that of the water 1. So this is also correct and this is also correct. We studied this in the chart or a full image of the solar system when we studied. All the details were given in that image. So the answer is option B. 2 and 3 are correct. Which of the following planets in the solar system takes the shortest revolution? So the answer to this will be Mercury. As we know, Mercury is closest to the Sun. If this is Sun, this is Mercury, and these are the orbits of other planets. So Mercury has a shorter orbit, so it will be taking a shortest revolution. So the answer is, easy answer is Mercury. So let's discuss this question. Consider the statements regarding equator of the Earth. Equator is the largest latitude of Earth, dividing the Earth in two equal halves. As we studied when we studied equator, that the equator passes through the center of the Earth and it is a 0 degree latitude, and all other latitudes become smaller as we go towards the pole from equator. So it is the largest latitude and it divides the Earth into northern and southern hemisphere. So the statement 1 is correct. The equator is the only line of latitude which is also a great circle. What is a great circle? Great circle is a circle which passes through the center of the globe. Can we let's see other latitudes. Does they pass through the center of the Earth? No. So equator is the only line of latitude which passes through the center of the earth, and hence it is a great circle. So again the statement 2 is correct. Let's see the third statement. Sites near the equator are good location for space sports as they have a faster revolution speed than other latitudes. We haven't studied anything related to that in our chapter, that how latitudes are related to the speed. So only 1 and 2 is the answer. Moving further, consider the following statements regarding latitudes and longitudes. Longitudes are angular distance of a place from equator, and latitudes are angular distance of a place from prime meridian. So these statements are, which of them are incorrect we have to find. Actually both are incorrect, and they are reversed. Longitudes are the angular distance of a place from a prime meridian, and latitudes are the angular distance from equator. So the answer is your, both are incorrect, C. This is all for chapter 1 and 2. Do revise these chapters carefully because this will help you in the coming chapters. So in next class we will study chapter 3 and 4, which is motion of the earth and maps. Thank you.